Okay, factoring is breaking up an expression into the smallest possible factors. So it's with these trinomials, if you can factor them, usually it's going to look like two binomials in parentheses. Okay, and we always want to check for common factors first. That is important. So what I mean by that, I'm looking at these three terms in this first example. There's nothing that goes into all three terms. The last term doesn't have an x, and they're not all even because this doesn't have a coefficient. So there is no common factor here, but if there was one, I'd want to factor that out first. Okay. Now there are many different methods you can use to factor. I'm going to use a diamond problem. I don't really care what method you're using if you're my student, if it is working for you. Okay, so but here's how a diamond problem works. I'm going to take that coefficient of the x term and put it in the top of this x, and then I'm going to put the 16 in the bottom, the constant. Okay, now this is like a little riddle. I'm looking for two numbers that are going to add to 8. The same two numbers will multiply to 16. I usually like to start with the bottom because there's actually an infinite amount of ways if you throw negatives in the mix, because you could do 10 and -2, right? But with the multiplication, it's pretty limited if we're using integers. So I'm thinking, just brainstorming ways I can multiply to get 16. Now I could also do the double negative versions, -1 times -16, but double negatives aren't going to add up to +8. So I'm looking for one of these pairs that add up to 8, and there we go. It's the 4s. Okay, so that's what I'm going to put on the left and right of the diamond problem. Okay, and the reason I did that is because it's going to suggest how to factor this. So I know if this is factorable, it will look like this, because I'm kind of thinking of FOIL. If I FOILed these together, x times x would give me x squared, right? So the big question, though, is what goes in the back of each of these parentheses, and that's what the diamond problem does for me. It answers that. Okay. Now that's the same number twice, so I've got a 4 at the end of each binomial, and I'm going to separate those terms with a plus sign. And you could try it out, FOIL it back together, and you should get x squared plus 8x plus 16. Okay, so there we go. By the way, since that's the same factor twice, you could write that like so, and that means the same thing. Okay, so there's often a lot of confusion between factoring and solving. Solving means you're finding the x value here that's going to make this equation true. Okay. Now I would factor this, and it's the same expression on the left-hand side of my equation here, right? So I would go through that same process I did from the last problem to factor this, but I haven't solved it yet. So since this is equal to 0, the awesome thing about factoring is that it allows you to write two different equations. I know something times something else equals 0. So the zero product property tells me that one of these factors has to equal 0. Either this equals 0 or this equals 0. And both of those, when I solve those, I get the same thing. So I get -4. You don't have to write it twice, but it is actually a double root. We'll get to that later, but I can just write x equals -4. That's the x value that's going to solve that equation. Okay, so I just want you to know the difference between factoring and solving. Solving, you have to go a step further and say what x actually equals. Okay, all right, so let's try this one out. I'm going to set up a diamond problem again. 12 goes on top, 32 on bottom. And I'm thinking, how can I multiply to get 32? Okay, and then maybe there's some others. I think that's it for the integers. And then I'm looking for one of those pairs that's going to add up to 12, and 4 and 8 works. Okay, so this is what should go in the back of each set of parentheses. Now some people might write x plus 8 times x plus 4. That's fine. Just have to be those two factors. It doesn't matter what order they're in. Okay. All right, let's look at the next one. Okay, I'm thinking, how can I multiply to get 5? There's only really two ways that I can do that using integers. Either 1 times 5 or -1 times -5. And when I try those out, neither one of them is going to add up to 2. this adds up to 6 and then to negative 6. So this doesn't work. And when that happens, that just means that this isn't factorable. You can't break this up. So you can write prime. It's prime. You can't break it up any further. Just like 7 is a prime number because you can only do 1 times 7. You can't break it up any further into integer factors. Okay? All right. Next up. All right. So I haven't been talking about looking for common factors on these, because there haven't been any yet. But this next one, there is. I should have really been talking about that every time, because you should always be thinking about that. When I'm looking at this next problem, I'm noticing 2, 4, 30. Well, those are all even numbers, so this does have a common factor. So that means I can factor out a 2. And then I'm kind of just thinking about distributing, right? Since I had 3 terms initially, I'm thinking, okay, 2 times something equals x squared. Well, that would be x squared. And then 2 times something equals negative 4x. That would be negative 2x. 2 times something equals negative 30. Okay? And you could try distributing the 2 back in, and it will put you where you started, so you know you factored that correctly. Okay? Now, when we say factor, the assumption is that it's not written, but this really means factor completely. So this is factored, but it's not completely factored because I can still factor the trinomial. Okay, so let's go ahead and try to do that. So assuming that the trinomial is factorable, which I'm not sure yet, I haven't tried it, but if it is, it'll look like this. Okay, so let's set up a diamond problem. I'm going to put negative 2, so the negatives come with the numbers there, the coefficients. So now I'm thinking, how can I multiply to get negative 15? Okay, so negative 1 times 15 is a pair, but also 1 times negative 15 is a different pair because those will add up to different things. Okay, and then I've got 3 and negative 5, negative 3 and positive 5, and that's about it. So I'm looking for one of those pairs that adds up to negative 2, and that is my winning combo right there. Okay, so I've got a positive 3 and a negative 5. Okay, now this doesn't say solve, and I'm looking at this, it's completely factored. I can't break any of the pieces up more, so that is finished. Okay, now, next problem, same thing, except now it's equal to 0. Okay, so I go through the same steps to begin with, but then I got to go a step further. I'm going to use the zero product property. I've got a bunch of things multiplied together that equals 0. So one of these things has to equal 0. So either 2 has to equal 0. Wait a second. That doesn't make sense, right? 2 doesn't equal 0. So let's just forget about that one. But we've still got x plus 3 equals 0 or x minus 5 equals 0. So that means x could equal negative 3 or x could equal 5. 2 solutions there. Okay? All right, on to this problem. All right, so these problems are more difficult when there is a coefficient in front of the x squared term. Okay? So sometimes you can just factor it out like I could here, but when I'm looking at this, I can't factor a 2 out because 5x and 3 aren't even numbers. They're odd numbers, right? All right, so this is going to get a little bit more complicated. So you can still do this with a diamond problem, but you got to mess with the problem first, okay? So, and again, if you have a different method that's working for you, that's fine. I'm going to put this little arrow to indicate that I'm going to mess with this problem. What I'm going to do, I'm going to take the 2. Since I can't factor it out, I'm going to take it and multiply it by the constant term at the end, okay? So that 2 is going to leave the front, so it's just x squared now. The 5x stays the same. But then I'm thinking 2 times 3 is positive 6. Okay? So this is my modified problem. And this I can factor with a diamond problem. Okay? And this is one that gets mixed up a lot because, well, people sometimes go for 1 and 6 here. But those would add up to 7, right? So 2 and 3 is going to be your winning combo. All right, So this factors like so. Now, but if you think about this, if you multiply these two binomials together, you're going to get x squared plus 5x plus 6, not this. Okay? So since I modified the problem, now I'm going to modify this answer. And here's how it's going to work. In the beginning, I multiplied by 2. So now I'm going to do the opposite of multiplying by 2. I'm going to divide by 2. I'm just going to divide the number parts by 2, though. Okay? And I'm going to write it like this. Right? So I divided this 2 by 2. I divided the 3 by 2 as well. Okay? So now I want to simplify as much as I can. 2 divided by 2 is 1. Leave myself really enough space here. And since I can't reduce this fraction anymore, you want to make sure if this said 6/4, reduce it to 3/2. That's going to make a difference. But I can't reduce any further. Okay? And if you still have a fraction after reducing, take the denominator and pull it out in front of the x. Okay? So I'm going to pull that 2 in front of the x, like so. And then the 3 is going to fall to the ground. And boom. There's my answer. Okay? And you could try foiling it back together, and it would work. It would get you back to 2x squared plus 5x plus 3. Okay? All right, so let's try it again. We're going to have to use a modified diamond problem. I can't factor that 2 out because 2 doesn't go into the middle term. So I'm going to modify this. Do a little of that. Okay? So the coefficient here of the x, you can think of that as 1x, right? So I've got a 1 up here and a negative 12. Okay? Multiplying to get negative 12, let's see. And you don't necessarily have to write all of these out. I'm just trying to show you my thinking. Okay? So those are all the possible ways I can multiply to get negative 12. I want a combo that adds to positive 1, and I found one right there. Okay, so that means I've got x, I wrote a plus. I can put them in either order, but it has, so I'll put the plus 4 first, and then the x minus 3 second. Okay, now that's not my final answer. That's what I see all the time. People just stick with that. But hey, that's why I did that arrow. I'm remembering I modified the problem. Now I've got to modify the answer. In the beginning, I multiplied by 2, so I'm now going to divide the number parts by 2. Excuse the bell there. Okay, then I'm doing the division here. And I can't simplify 3/2 anymore, so I pull that 2 out in front of the x. Okay, and there we go. Okay. I've got to take a break because I got a class coming in. Okay. So I have factored this over here, which looks very similar to this problem. This one's just asking me to solve. So I would go through all of these same steps to factor the left side of this. By the way, you'd only want to factor if it's set equal to 0 because we want to use the 0 product property. If it's not set equal to 0, then it's not going to do us any good to factor the left side. So like say that it said plus 6, it said the 6 was over here. I'd want to move it to the left first before I factor. Okay, so we've got it factored. Now let's use the 0 product property. One of these two products has to equal 0. So either x equals negative 2, or if 2x minus 3 equals 0, then let's see, I'll add 3 and divide by 2. Then x would equal 3/2 or 1.5 if you prefer. Okay. All right, let's give this next one a shot. So some people are going to go straight to trying to do a modified diamond problem thing here, but it'll actually, it's not going to work because there is a common factor. You have to factor out the common factor first. If you miss that, modified diamond problem, it's not going to quite get you the right result. Okay, so I'm seeing that, hey, all of these are even numbers. Let's factor out a 2. So this is going to be, I don't know, I put the equal sign there, but all right, I've got 3 terms. 2 times something is 6x squared. 2 times something is negative 2x. That would be negative x. 2 times something is negative 8. And I could try multiplying it back in if I wanted to do that to test it out, and it would come out to this. Okay, so now I'm going to attempt to factor further. So I want to see if I can factor that trinomial, the 3x squared minus x minus 4, further. Okay, so I'm going to do a little problem off to the side then. Okay, so for this one, there is no common factor anymore. So here's where I'm going to do the modified diamond problem thing. Okay, so let's see, I've got 3 times negative 4 is negative 12. Okay, and then I'm going to set this up using a diamond problem. Pardon the bell again. Okay, so I'm thinking of ways to multiply to get negative 12, and I want those same two numbers to add to negative 1. So how about 3 and negative 4? 3 and negative 4 is going to be the winning combo then, okay? So that means that this is going to factor into x plus 3 times x minus 4. But I have to undo what I did at the beginning. In the beginning, I multiplied by 3. I want to do the opposite of that now. I'm going to divide by 3. Okay? I'll reduce as much as I can. This one I can't reduce any further, so I'll pull the 3 out in front of the x. 4 falls to the ground. So that is what that second trinomial factors to. Okay, but remember, we still had factored the 2 out at the beginning. A lot of times people will forget all about the 2, but it is still part of my factored solution there. Okay? All right, next up, this one's a little weird. You might recognize this is actually a difference of squares. You could think of this as x squared plus 0x minus 49, and you could factor it with a diamond problem, and it will work. Okay, but you also might notice, okay, I've got two things subtracted, so it's a difference. And this is a perfect square because x times x is going to equal x squared. 7 times 7 is 49. And then there's a little pattern that works here. When I'm factoring this, I know, hey, I take the x's are going to go in front, and the 7's will go in the back. And then one of them is positive and one of them is negative. You could get that same result by doing a diamond problem like this, but it's a quicker shortcut. With a difference of squares like that, it's always going to follow that pattern, okay? So this next problem is also a difference of squares. So I'm thinking what times itself equals 25x squared? Well, 5x times 5x equals 25x squared. And then what times itself would be 49y to the fourth? That would be 7y to the second times 7y to the second, right? 7 times 7 is 49. Y squared times y squared is y to the fourth. So then it's going to follow this pattern. I've got a 5x in the front, a 7y in the back. One of them is going to be a plus and one's going to be a minus, just like that last problem. And that's how that difference of squares works. And that's it. All right. See you next time.